Good morning again, guys. Welcome to day 5, where we're going to be problem solving in 3 dimensions today for our trigonometry unit. This is section 5.8 in your textbook. Your textbook's great for this one, so we're going to go here. To be honest, it's pretty straightforward. You're going to be using your primary trig ratios. You're going to be using sine law and cosine law. If the ambiguous case happens to show up, just double check, but for the most part, you should be okay. Okay, so I've got 2 examples to work through today. The hardest part of these scenarios is drawing the diagram. If you're struggling with the diagram, you know what, this time around, don't panic too much about it. Try and focus on the ones that are easy for you to draw. If there's really a problem with your questions, chances are it is just the way the diagram's been drawn. So here we have a surveyor. We're trying to find height. So a lot of these problems, these 3D ones, you're just going to have to use your trig tools more than once. So here I've got this height. You can see it's a right angle triangle. I don't even need to read the rest of the question. I'm trying to find this. If I had this side down here, length DC, this would be a straightforward trig ratio question, but they didn't give it to me. So I'm going to look at the triangle underneath, and hopefully we can get some information from here to figure out what D is. So when I look at triangle BDC, you should notice that I have 2 angles. It's easy for me to get this one here, and that would give me an opposite ratio, and then I could find the other opposite ratio. So I'm going to be using my sine law in order to solve this problem. So the first thing that you've got to do is figure out this angle. So you can take 180 degrees, you can subtract 63.283 and 72.418. You should get 44.299. So this is 299. Okay, now that we have the angle, we can set up our sine law, and I'm just putting these kind of dotted lines here so you can see which ones to connect in your sine law. So since I'm looking for, we're going to call this, I guess we could call it side B, I suppose, because it's opposite from this B. Since I'm looking for this side, I'm going to put that first. And the angle that goes with it is 63. So B is going to be over 63.283. Okay. And that ratio, whatever that is going to be equal to this set. Now, because I put a side on top, I have to put the side on top of my other fraction. So here I'm going to put the 4.35, and it's going to be over sine of 44.299. 44.299. Okay, I have to get the B by itself, so I'm going to take the sine 63, sine 63.283. I'm going to times whatever that answer is by 4.35. I swear my writing on this has gotten worse. And then we're going to divide by sine of 44.299. Okay, so take a second. Plug this into your calculators. I'm doing it with you, so it'll just take a second. Plug it in and hopefully we'll get the same answer. So sine of 63.283, figure out what that is. I got around 0.89. I'm going to times it by 4.35. Now you're looking at around 3.88. Then you're going to divide by sine of 44.299. And you should get around 5.56. Okay. Now, one of the things that you should realize is that your angles are pretty reflective of the sides. So the largest angle will have the largest side. So I'm just going to check here. I got 5.5 here, and its matching angle is 63. This one was 4, which is smaller, and the angle 44 is smaller. Okay, so my answer seems reasonable. Okay, so B is equal to 5.56. 5.56. Now we can use our basic trig ratios to figure out the height. Okay, so if that's my angle in question, opposite over adjacent, we're going to be using our tan, and I know I should be working downwards, but I just want to show you here so you can see the diagram. So tan of 15.217 is going to be equal to h over 5.56. Oops, store. Oh, that didn't work. 5.56. Now I need to bring the 5.56 up here. And I'm so sorry. Usually I keep my answers pretty accurate, but I just erased something. And we're going to times it by 10 to 15.217. You should get a height of approximately 1.512. Okay, so based on the survey, that's really what you're looking at. We're dealing with, it doesn't tell us the units, meters, kilometers. Okay, so 1.52 kilometers. Okay, and that's it. So a lot of these problems, all you're doing is just using, having more than one step, any trig ratio or formula more than one time. Okay, this one here, again, we'll take a look one more time. In case you need it, if you're comfortable, you guys can start working on your questions. If not, you can watch the second example just to see another one. Okay, so here we have a second triangle. We're trying to determine the value of x. That would be, if I'm looking at angle A, that would be our hypotenuse because it's across from the 90. Now, when I come down here, they don't tell me that little angle and this little angle. We don't know quite exactly how it's meeting. What I do know is that this side is also 27 because this side is 27. So I have two sides and the contained angle down here, which means I could use my cosine law to find this third side. And we'll call this third side A, okay? So let's quickly plug in our cosine law. So I know that a squared, let me just do this super fast, just because it's so much easier to see than my actual scribble handwriting, my pen writing. Okay, so a squared is going to be 27 squared I'll replug it in a second. There we go. So 27 squared for this side plus 27 squared for that side minus 2 a times c, or b to a times, because in this case it'd be b times c, times cos, small c, of our angle, which in this case is 70. Okay. I always like to tell my students to please, 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 when they are evaluating these, to make sure you see 3 clear terms before you move on. I find a lot of mistakes happen when people mess up their BEDMAS rules for some reason here. So please take your time. So 27 squared, you should get 729. So we've got 729 plus 729 minus, and now I tend to plug this last part here all at once. So cos of 70 times 27 times 27 times 2. Okay. I got 498.665. I'm going to keep all those decimals. I'm going to keep all of the decimals because if you can keep more decimals, the more accurate your answer is. So please keep them for now. All right, I'm going to store that in my calculator. So 729 plus 729 minus our 498. We should end up I ended up with 959.33, which, there we go, let's try this again, 959.33. Okay, take the square root of each side. I'm sorry, take the square root of each side so you can get the square root of 959. When you take the square root, you should get around 30.97. Again, I am keeping all of my decimals. Yeah, you could have rounded, but I'm going to keep them all to keep my answers accurate because we're going to use this number later. So the more decimals, the better. So A is 30.97. So now when I come back up to my triangle, I have a right angle triangle. This is my angle right here. And I can use a primary trig ratio to solve for x. So I have opposite over hypotenuse, that would be sine. Now, you could use your cosecant here if you're comfortable with your reciprocal angles. Either way, you do have to convert them back into sine, so it doesn't particularly matter. So sine of 27 equals 30.97. That looks like a 397 over x. Now my x is on the bottom, so I've got to bring it up top. I'm going to multiply both sides by x, and then I will bring my sine 27 down. So this is x equals 30.97 divided by sine of 27. You can plug that all in one step. You can take multiple steps. And sine of 27. You should get about 68.2. Okay. Oops. 68.2. Okay, and we're dealing with centimeters here. Okay, and that's it. So it's just really creating multiple triangles and using the information from one triangle to get the answer for the second one. Okay, have a great night, guys, and we will see you next time.